Okay, so should be live. We shall see if I am. I do generally always check these days because there's always something going on. So let's just make sure. Seems like that's not it. I'm probably streaming still, to be fair, but I do want to. Oh, yeah, it says I'm live. Okay, perfect. Okay, so hey everyone, Chloe here. Um, I guess more doing things for the marmaj Research DAO, probably moving forward in general. And trying to get marmaj labs going and get this marmaj hackathon stuff going in Antigua. But for today, I've kind of been trying to stay true to the vision of the Marmaj Foundation to be, chain agnostic. And I haven't really done much research outside of the near ecosystem in quite a while. And so this morning I was just like, what else besides near is going on? A lot of people have been talking about Cosmos recently, so I have been wanting to jump in. Got to shout out Mike P. For jumping over there, and I've been definitely more interested since then. But yeah, I'm just going to read the Cosmos white paper. I think I've read through some of it, at least a good majority of it in the past. But I definitely, it was years ago, and so I think just a good idea to get myself refreshed. It's probably quite long. It's actually not that long. It seems like this must not be the full thing. But we're just gonna get started and see where we get. Uh, let's see. Okay, so literally there's a few, links here. We might just go through all of it and let's just get started. So this is the Cosmos white paper. A network of distributed ledgers. Very fancy. I follow Ethan Butchman on Twitter. Jaquan, I'm not sure if I do follow on Twitter, but I follow a lot of random people on Twitter just to follow their research stuffs in general. If you can read this on GitHub, that's where. Oh, then that seems like a better place. I'm already gonna go somewhere else, hopefully. Okay, so let's see if they make it. Ooh, Cosmos Network. Oh, that was V1. This is V2. Wait, this doesn't seem different. Okay. Let's see if it's easy to find. It wasn't easy to find on their website. It was too much marketing stuff. This might be better. Okay. Ugh. Let's just see if they have a whole thing just called white paper. That'd be super cool. I don't think they're gonna have something called that. Mainnet. This is how to run it. Man. I kind of wanted it to be super simple to find. White paper. Okay, sure. What? You lie. See, that wasn't as fun. I was assuming I'd be able to read this, and then it says, oh, the first note is wait. I'm so confused. Let's just read this. Because this is V1, and they're saying they're in a V2. I'm just going to start reading. So, bear with me. This is annoying, though. Be more clear with what you mean. Anyways, the combined success of the open source ecosystem decentralized file sharing and public cryptocurrencies has inspired an understanding that decentralized internet protocols can be used to radically improve social. Oh yeah, and for those no one has to watch this, by the way. This is just for me. I'm literally just gonna read this out loud because I learn best. I'll retain some of the information if I read it out loud. So I used to do this all the time, and yeah. So Ernest, I don't know what you're gonna be able to cut up here. I'm not even. I'll send you the link to this. and let you know. But yeah. Where was I? This is like a really boring introduction though, but I'm still going to read it because it's interesting somewhat. We have seen specialized blockchain applications like Bitcoin, a cryptocurrency, zero cash, like cryptocurrency for privacy, and generalized smart contracts platforms such as Ethereum, with countless distributed applications for Ethereum virtual machines such as Argur, prediction market, or the DAO. I like that one. To date, however, these blockchains have suffered from a number of drawbacks, including their gross energy efficiency, poor or limited performance, and immature governance mechanisms. I'm excited to see what they propose for governance, actually. There we are. Proposals to scale Bitcoin's transaction through such as segregated witness. I think they added, Bitcoining and vertical scaling, but all remain limited by the capacity of a single physical machine in order to ensure the property of complete auditability. The Lightning Network can help scale Bitcoin transaction volume by leaving some of the transactions off the ledger completely, and is well suited for micropayments and privacy-preserving payment rails, but may not be suitable for more generalized scaling needs. Sounds good. An ideal solution is one that allows multiple parallel blockchains to interoperate while retaining their security properties. This has proven difficult, if not impossible, with proof of work. Merge mining, for instance, allows the work done to secure a parent chain to be reused on a child chain, but transactions must still be validated in order by each node, and a merge mined blockchain is vulnerable to attack if a majority of the hash power on the parent is not actively merge mining the child. An active review of alternative blockchain network architectures is provided for additional context. So they just have a lot of stuff to read into if you'd like to keep digging in, which I like, actually. And we provide summaries of other proposals and their drawbacks in related work. Ooh, there's so many links. I like this. This is actually, this is why. It starts, anyways. I'm going to keep going. Here we present Cosmos, a novel blockchain network architecture that addresses all of these problems. Ooh, fancy. Cosmos is a network of many distributed blockchains called zones. The zones are powered by Tendermint BFT. Oh, I've read the BFT paper, not the Cosmos paper. That makes sense. Which provides a high-performance, consistent, secure PBFT-like consensus engine where strict fork accountability guarantees hold over the behavior of malicious actors. The Tendermint BFT consensus is well suited for scaling public proof-of-stake blockchains. Interesting. The first zone on Cosmos is called the Cosmos Hub. So that's like the beacon chain in Ethereum. The Cosmos Hub is a multi-asset proof multi-asset proof-of-stake cryptocurrency. Cool. With a simple governance mechanism which enables the network to adapt and upgrade. So they build governance into the chain similar to, I guess, Polkadot. I wonder how Near is going to handle that. Interesting. In addition, the Cosmos Hub can be extended by connecting other zones. Cool. The hub and the zones of the Cosmos network communicate with each other via an internet blockchain communication protocol, IBC, kind of virtual UDP or TCP for blockchains. Okay. So how blockchains communicate with each other. Sorry, I'm eating pistachios while I read this. So, tokens can be transferred from one zone to another securely and quickly without the need for exchange liquidity between zones. That's good. Instead, all intra-zone token transfers go through Cosmos Hub. So we're saying you don't need liquidity because everything goes to the hub, which just keeps track of everything. Okay. So as long as the hub's good, you're good. Just trust the hub. The hub isolates each zone from the failure of other zones because anyone can connect a new zone to the hub. Okay. So Near is trying to parallelize everything, right? And just build more roads. Whereas this is send all traffic through us. but will allow communication to go through more efficiently. So maybe like planes and airports. Interesting. Maybe. I'm not sure that makes sense, so please feel free to correct me. Which is why I do record this. I can correct myself in the future. Isn't that crazy? I can tell myself to correct myself. Wild. Yeah. The hub isolates each zone from the failure. Yep. Yeah. Okay. Tendermint. Okay, so this is, I guess, the paper that I have read, but let's get a value, overview of it. In this section, we describe the Tendermint protocol and the interface used to build applications with it. For more details, see the appendix. So you have validators. In classic BFT algorithms, each node has the same weight. In Tendermint, nodes have a non-negative amount of voting power, and nodes have positive voting power are called validators. Validators participate in the consensus protocol by broadcasting 100% of votes to agree on the next block. Validators' voting powers are determined at genesis or are changed deterministically by the blockchain, depending on the application. For example, in the proof of stake application like the Cosmos Hub, the voting power may be determined by the amount of staking tokens bonded as collateral. Fractions like 2/3 and 1/3 refer to fractions of the total voting power, never the total number of validators. Okay, unless all the validators equal weight. Okay. Greater than 2/3 means more than 2. Okay, that makes sense. Greater than equals 1/3 means at least. That's helpful. Thank you. Consensus. Tendermint is a partially synchronous BFT consensus protocol derived from the DLS consensus algorithm. I don't know if I've read this one. Can't remember. Okay, not the time for this, but it's hard to remember what I've read or not read. That's why I try and record these things, because then I can just search it on YouTube. Tendermint is notable for its simplicity, performance, and fork accountability. The protocol requires a fixed known set of validators, where each validator is identified by their public key. Validators attempt to come to a consensus one block at a time, where a block is a list of transactions. Okay. Oh, the pistachios all the way shut. I'll save that for later. Voting for consensus on a block precedes its rounds. Each round has a round leader or proposer who proposes a block. The validators then vote in stages on whether to accept the block or move on to the next round. Okay, very simple. Like, all the full details are everywhere else. Okay, let's see what they put here. Okay, so they do just put to the current. Ooh, okay. So you can just like literally read it all. That's super cool. I like how they just like it there. It is updated here. Tendermint security derives from its use of optimal betting time fault tolerance via supermajority voting and a locking mechanism. Together they ensure that at least 1/3 of the voting power must be designed to cause a violation of safety. So you need to have more than 1/3 of people being malicious, or like nodes malicious, where more than 2 values are committed. I'm actually not sure what the heck you mean by more than 2 values committed, but maybe you have to like do it twice in a row, like in 2 different blocks. Anyways, if any set of validators ever succeeds in violating safety, or even attempts, they can be identified by the protocol. Okay, so maybe they're saying they gotta do it twice, but then you would know in the first round, so you'd be able to like slash them, and they couldn't do it in the second round because it'd be like way harder to slash everyone. But anyways, this includes both voting for conflicting blocks and broadcasting unjustified votes. So seems relatively secure if this is true. If you could also have this, 2 or more values, I guess seems it's a very important part, I guess. If you know in the first, because if someone tries, you know, and then to actually attack, you'd have to do it again, and then you'd slash them. Hopefully, like, as long as you can. I mean, if someone can like stop the slashing or something, maybe that's a problem. But despite its strong guarantees, Tendermint provides exceptional performance. That's good. In benchmarks of 64 nodes distributed across 7 data centers on 5 continents on commodity cloud instances, Tendermint consensus can process thousands of transactions per second with commit latencies in the order of 1 to 2 seconds. Not bad, I guess. 1 to 2 seconds is a long time, but not really, I guess. I'm always thinking of like the end consumer, not like data centers. So I'm always, yeah, anyways. Notably, performance is well over 1,000 transactions per second is maintained even in harsh adversarial conditions, with validators crashing or broadcasting maliciously crafted votes. See figures below for details. Yeah, then it'll go through all like the tested and light clients. A majority benefit of Tendermint's simplified light client security, making it an ideal candidate for mobile and Internet of Things use cases. While a Bitcoin light client must sync chains of block headers and find the one with the most proof of work, Tendermint light clients only need to keep up with the changes to the validator set. Okay. Which shouldn't be much. And then verify that greater than 2/3 of the pre-commits in the latest block to determine the latest state. I guess because they use, what's it called, like erasure coding, whatever. So you only need like part of the blocks. Okay, cool. As long as people aren't malicious. Ooh, okay. Succinct light client proofs are enabled. All right, enable inter-blockchain communication. Did they just link their own paper in their paper? What? I'm so confused. Right? Like, am I going crazy? Anyways, that's funny. Oh, let me do that. Preventing attacks. Tendermint has protective measures for preventing certain notable attacks, like long-range, nothing at stake double spends, and censorship. These are discussed fully in the appendix. Okay, so long range, nothing at stake. Well, yeah, you get to lock up your tokens and bond them or whatever, yada yada yada. Okay. ABCI. The Tendermint consensus algorithm is implemented in a program called Tendermint Core. Tendermint BFT, application agnostic consensus algorithm that can turn any Tendermint block application into a distributed or calculated blockchain. Tendermint BFT connects which blockchain applications via the application blockchain interface. I always like ABI, but I don't like ABCI. It's confusing me. It's a different thing. The interface that defines the boundary between the replication engine, the blockchain, and the state machine, the application. By using a socket protocol, we enable the consensus algorithm running in one process to manage an application state running in another. Thus, the ABCI allows for blockchain applications to be programmed in any language, not just the program language that can get written in. Additionally, the ABCI makes it possible to easily swap out the consensus layer. Okay, so that sounds cool. Like they just lay it out there so like matter of factly, but okay. I feel like There's a lot of like papers behind all of these papers. ABC algorithm, climb down everything. Okay. Okay. Previously, the ABC was referred to as the TMSP. The community has provided a number of additional implementations. See the Tendermint ecosystem. Okay, so I guess this is like, well, I mean, swapping out whatever consensus mechanism you want and programming language. A lot of them just let you switch out, like, use any programming language, but like, not consensus. Cool. We draw an analogy with well-known cryptocurrency Bitcoin. Bitcoin is a cryptocurrency blockchain where each node maintains a full, audited, unspent transaction output database. If one wanted to create a Bitcoin-like system on top of ABI, Tendermint would be responsible for sharing blocks and transactions between nodes, establishing a canonical immutable order of transactions, the blockchain. So Tendermint, right, takes care of the communication and the actual like order of nodes. And the ABCI, the actual application, it seems, so far, with my limited knowledge, right, is maintaining all the trend, like the balances, I guess, like the state of the balances of all the accounts. Doing all the actual manual labor of validating signatures, I guess, as things go on. Preventing transactions from spending non-existent funds, which I guess makes sense because it's taking care of the balances. And allowing clients to query, yeah, because it's taking care of the balances. Tendermint is also able to decompose the blockchain design by offering a very simple API between the application process and the consensus process. Okay. So they just split things up, I guess. Cool. Cosmos is a network of interdependent parallel blockchains that are each powered by classical BFT consensus algorithms like Tendermint. So maybe not necessarily Tendermint, but okay, so because they don't have to be exactly Tendermint, as long as they're close enough, they can connect. Didn't like Near add some cryptography recently, I think, that allowed it to connect to Cosmos? Can't remember, honestly, but I think so. I think you add the cryptography and anyone could connect. I like that. Like you know, the way that works. It's very like open and sharing of it, of it, I guess. The first blockchain will be Cosmos Hub. Cosmos Hub connects to many other blockchains or zones via a novel inter-IBC protocol. The Cosmos Hub tracks numerous token types and keeps records of tokens in each zone. Tokens can be transferred from one zone to another securely and quickly without the need for liquid exchange. Okay, I already read that in the intro, didn't I? Okay, I actually have made a problem looking at this today. So this application not released. Going to be for example, zones are defined. Bitcoin, Go Ethereum, Cryptonodes, Zcash, or any blockchain system can be plugged into Cosmos Hub. Yeah. So these zones allow for Cosmos to scale infinitely to meet global transaction demand. Zones are also a great fit to distributed exchange, which will be supported as well. So I guess, yeah, like if you could plug, it's kind of like saying any chain can be a layer 2 on Ethereum. Any chain can just plug into Cosmos and be a zone. Like, you're just kind of, I guess, saying which validators are going to win out. Oh gosh, we're just playing all PvP, eh? And it's just who's going to run Like, which validators are gonna soak up the most liquidity? This is kind of scary, but whatever. Just run a validator, kids. Okay, not financial advice. Oh my gosh, don't throw me in jail for that. I'm joking. Kinda. Cosmos is not a single distributed ledger, and Cosmos Hub isn't a walled garden or the center of its universe. Because usually in proof of stake, you gotta like ask to be a validator. There's always weird things. But anyways, we're designing a protocol for an open network of distributed ledgers that can serve as a new foundation for future financial systems based on principles of cryptography, sound economics, consensus theory, transparency, and accountability. I like that. I guess Near just wins in the respect that you get that 1 to 2 second finality, and you get it across an entire ecosystem. But like, if you just build on a hub that has 1 second finality, like Near could be the hub, or you could, yeah, it really depends which blockchain has the most security, because dang, that's crazy. Wow. It's all just the economic security of the chain and where it makes sense to keep building and accruing value. We designed a protocol. Yeah. Tendermint BFT. The Cosmos Hub is the first public blockchain for the Cosmos network. Okay. Yeah, the Tendermint open source project was born in 2014 to address the speed, scalability, and variety of issues of Bitcoin proof of work algorithm by using the improving upon proven BFT algorithms developed at MIT in 1988. The Tendermint team was the first to successfully demonstrate a proof of stake cryptocurrency that addressed the nothing at stake problem suffered by the first generation proof of stake cryptocurrencies NXT and BitShares. Today, practically all Bitcoin mobile wallets use trusted servers to provide them with transaction verifications, because proof of work required waiting for many confirmation reports. Those fantastic have already been demonstrated on services like Coinbase. Unlike other blockchain sectors, Tendermint offers instant, improvable, secure mobile client payment verification, since Tendermint is designed to never fork at all. Interesting. Because like in the Near example, that's interesting. Mobile wallets can receive instant transaction confirmation, which makes trustless and practical payments a reality on smartphones. This has, so even if the block time is 5 seconds on the hub, you can still get instant verification because there's not going to be a fork. So for all intents and purposes, as a user, you're fine, and then as a bank, you wait 5 seconds, which is reasonable. That makes a lot of sense. Let's continue. But this is as well. Yeah. Like your fridge doesn't actually care if you're right or wrong, like normally, and then it'll check in 5 seconds. Like it's not a big deal. That's crazy. I mean, that makes a lot of sense. Like, you don't have to always be in 1 second. Although there are times when you do want it in 1 second. So, yeah, I don't know. I can't think of the application where that's needed, though, to be fair. So, we'll see. Validators in Cosmos have a similar role to Bitcoin miners, but instead use cryptographic signatures to vote. Validators are secure, dedicated machines that are responsible for committed blocks. Non-validators can delegate their staking tokens called atoms to any validator to apportion block fees and rewards, but they incur a risk of getting punished, slashed. Oh, so they already have slashing. I wonder if they actually have slashing implemented. That'd be really cool if they do. Because Near does not have slashing implemented yet, which is probably like a pretty big deal. I don't know. If you can't get slashed, that's not good. I don't know. But the proven safety guarantees of Tendermint BFT consensus and the collateral deposit stakeholders, validators, and delegators provide provable, quantifiable security for nodes and light clients. Okay. I actually am curious about the governance a little bit. I know they have like on-chain governance, which is pretty interesting. Distributed public ledgers should have a constitution and a governance system. Near's trying to build out their constitution now. from a community's point of view. And I know this is more the Ethereum way of doing things, so I'm actually totally fine with that as well. But it's it's an interesting process. Bitcoin relies on the Bitcoin Foundation and mining to coordinate upgrades, but this is a slow process. Ethereum split into ETH and ETH Classic after hard forking to address the DAO hack, largely because there was no prior social contract nor mechanism for making such decisions. Validators and delegators in the Cosmos Hub can vote on proposals that can change preset parameters of the system automatically, such as the block gas limit, coordinate upgrades, as well as vote on amendments to the human readable constitution that govern policies. Oh, that is. I'm such a proponent for like social influence in these types of upgrades, but this is still fine. I don't know. Cosmos is doing pretty well right now, so I don't know. Like it's working in the wild. So. The Constitution allows for cohesion among the stakeholders on issues such as theft and bugs, such as the DAO incident, allowing for quicker and cleaner resolution. Now, obviously, it's just a document. Now, you can just come together with your validators and have a document in Discord, and it can work out just as fine. But, knowing that, who voted on what, it's human readable parts as well as upgrades and everything else. That's pretty cool. Each zone can have their own constitution and governance mechanism as well. Interessant. So then, like, Cosmos Hub would obviously have its own way of dealing with things, and then like each, I guess, smaller organization. And I wonder if they'll have like the para chain. Like, I like this para thread thing, where you can like lease security, but I guess it would be the same. Like, obviously, you can just like build an L2 on top of someone's hub, someone's zone or someone's chain. So yeah, you can just lease security however you want. That's super cool. You're just like, at the end of the day, it's going to pay the main Cosmos Hub and those validators. Interesting. For example, the Cosmos Hub could have a constitution that enforces immutability at the hub, so no rollbacks, save for bugs of the Cosmos Hub node implementation, while each zone can have their own policy regarding rollbacks. It's kind of like Ethereum has its own way of doing things, and each L2 on Ethereum could, be like, the zones. It's all kind of the same. Every blockchain is kind of doing the same thing, but different consensus algorithms to solve it, and different, storage and governance and these types of solutions. By enabling interoperability among different policy zones, the Cosmos network gives its users ultimate freedom and potential for permissionless experimentation. I do see that. Truly being able to take billions of dollars and use it for permissionless experimentation seems like it would be happening on Cosmos, which does sound very, very, very interesting for a place to run a node, or run a validator. I'll probably run a node on this machine right here, a node at least. I don't know what a validate. I don't even have a Cosmos token. Like, I don't even know how that works. I've never looked into it. But yeah, I'd run a Cosmos node here and just start digging into things as I get into the academic side of this. So hubs and zones. Here we describe a model of decentralization and scalability. Cosmos is a network of many blockchains powered by Tendermint, while existing proposals aim to create a single blockchain with total global transaction ordering. Cosmos permits many blockchains to run concurrently with one another while retaining interoperability. At the basis, the Cosmos Hub manages many independent blockchains called zones, sometimes referred to as shards. Okay, so zones are similar to shards. In reference to the database scaling techniques of sharding, a constant stream of recent block commits from zones posted on the hub allows for the hub to keep up with the state of each zone. So pretty much each blockchain just shares its information to the hub, and so the hub just knows what's going on. Likewise, so the hub never forks because the hub always just knows and just chooses what it wants to do based on the hub. Doesn't care what the zones are doing. That's super cool. The zones can fork. But if you spend on the hub, there's no forking, so you're fine. If you spend on a zone, wait 5 seconds. Interesting. Okay, that's like, so they can build a stablecoin into their consensus, and that would be, well, stablecoin. What does that even mean? Anyways, but zones do not communicate with each other except indirectly through the hub. Yeah, that makes sense. Packets of information are then communicated from one zone to another by purchasing Merkle proves evidence that the information was sent and received. This mechanism is called inter-blockchain communication, or IBC for short. Any of the zones can themselves be hubs to form an eclectic graph, but for the sake of clarity, we only describe the simple configuration where there's only one hub and made monohub subs. Okay, so so near, for example, could upgrade or change, or not upgrade, but change or even fork. So you could fork near, add Tendermint, become a hub because let's say you had your own near thing here. You could have these zones connect to your hub, and you could have them post information, and you could provide your own security. But again, I think it's the biggest not battle, but the thing happening is who can soak up the most economic security based on their consensus algorithm, which I guess is not even close to be seen yet. So very exciting stuff. The hub. The Cosmos Hub is a blockchain that hosts a multi-asset distributed ledger where tokens can be held by individual users or by zones themselves. These tokens can be moved from one zone to another in a special IBC packet called a coin packet. The hub is responsible for preserving the global invariance of the total amount of each token across the zone. So yeah, it keeps the balance. Okay. IBC coin packet transactions must be committed by the sender, hub, and receiver blockchains. Okay. Since the Cosmos Hub acts as the ledger for the whole system, the security of the hub is of paramount importance. That makes sense. The hub basically does everything at this point. Well, each zone, same with Shard, yeah. Well, yeah. Well, each zone may be a Tendermint blockchain that is secured by as few as 4, or even less if beacons are needed. The hub must be secured by a globally decentralized set of validators. So they just make it so that the chains can be not as secure, but same thing as sharding. Yeah, with near. Such as so they're making it so that you have this really, 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 really secure central hub, and you're saying, okay, these other chains don't have to worry about security as much because the hub is secure, and you know that as long as something went through the hub, you know it went through a secure thing, so you're good because this thing is super, super, super secure, and it went through that. And that would be more expensive to go through, and other places might be cheaper where you get less security guarantees, but you pay a bit less, and you have other hubs. That is so interesting because you could have near could be a hub that's a bit less secure, and I like this because it doesn't there's no fighting going on. They're saying the hub has to be the most secure, and that's fine, but there could be other hubs. But what happens if a different hub gets more economic security than the main hub? I'm not smart enough for that. But that's kind of my question. Because if this hub can never fork, other zones could fork, I guess. But if other zones can be hubs for other zones, then that hub can fork. Not the Cosmos hub, but other hubs. But they're all on Tendermint. So I'm still having, that's probably where I'm having my biggest issue. But I'll keep reading. And yeah. The Cosmos Zone is an independent blockchain that exchanges IBC messages with the hub. From the hub's perspective, a zone is a multi-asset, dynamic membership, multi-signature account that can send and receive tokens using IBC packets. Yeah, that makes sense. um, like a cryptocurrency account. A zone cannot transfer more tokens than it has, but can receive tokens from others who have them. A zone may be designed a zone may be designated as a source of one or more token types, granting it the power to inflate that token supply. Gosh, okay. Like, it all makes sense on paper, and I'm seeing it happen in real life, and I'm just like, it sounds the same as like L2s and every other consensus. I mean, with the beacon chain, you have that having all the economic security and like things off of it. I always did feel though that ETH2, like Ethereum with shards, made more sense than Cosmos, but I mean, because you could just upgrade Ethereum to add these things, and Ethereum plugs in too. Cosmos, the IBC in general sounds super cool to make sure all blockchains can communicate efficiently, but I'm having a hard time understanding what happens when other zones get bigger than the hub. A Cosmos zone is an independent blockchain that exchanges IBC messages with the hub. From the hub's perspective, a zone is a multi-asset. Okay, yeah, anyway, sorry. I'm here. Atoms of the Cosmos hub may be staked to validators of a zone. What? Oh, because you can validate a zone as well. Okay. While double spend attacks on these zones would result in the slashing of atoms with Tendermint's fork accountability. Oh, because the atoms are in the hub being, like, committed to a zone. And yeah. A zone where greater than 2/3 of voting power are Byzantine can commit an invalid state. The Cosmos hub does not verify or execute transactions committed on other zones. So it is the responsibility of users to send tokens to zones that they trust. So within the hub, you're fine. You go off to this zone, you could just be getting totally destroyed. And the hub doesn't verify the zones. But if something happens in the zone, they would get slashed, like the validators of that zone. Of that zone only, though. Which, like, yeah, I don't know. Like, it's interesting. In the future, the Cosmos Hub's governance system may pass hub improvement proposals that account for zone failures. For example, outbound token transfers for some or all zones will be throttled to allow for emergency cert breaking of zones or temporary halt of token when an attack is detected. Interesting. Man. So you could like upgrade to allow the hub to be like a watchtower for other zones, which I guess would just cost more. They would just build it into the cost. Interesting. IBC. Now we look at how the hub and zones communicate with each other. For example, if there are 3 blockchains, Zone 1, Zone 2, and hub, and we wish for Zone 1 to produce a packet. Wait, have I been streaming for an hour? I think I have been. If I have been, I'm going to stop here. I mean, the paper's been fun to 45 minutes. Yeah, I'm going to stop here. Paper's been fun to read. I think this is a good place to stop. Or else I'll just read it all day. Yeah. Stop for a bit. Pretty fun paper, actually. A lot like hidden in the weeds, and but this is making me more excited to see like Cosmos just continue to exist in the ecosystem. I think Near can actually. I'll do a quick search actually right here and just be like, Cosmos connect to Near. Yeah. Yeah, near protocol enabling IBC into Cosmos. What does this mean for Cosmos? Near Cosmos is blossoming. Multi-chain feature is near. And first of all, what is near? So yeah, near connected. Yeah. Yeah, I mean, yeah, IBC. Okay, so you don't have to pay the hub to use it, to post transactions there. See, that's what I want to understand more. Like, how does the payment work? Who pays the validators? Because this person's saying you don't have to pay the hub to use it, and I've heard this before on like Twitter. I don't look into like, again, I have not looked into Cosmos nearly enough, and that's why I'm reading the paper. And so we're gonna dig. I'm gonna dig into, how validators get paid, because like obviously people on Near are going to pay in Near to send messages to the hub, right? And if all the messages have to go through the hub, I'm assuming there's got to be some fees paid. I just like, if you connect to the hub, you got to have validators validating your chain or connections, and those validators gotta get paid in something. So yeah, I'm not sure I understand exactly how it works, but I'll keep reading into it. And yeah,